Hello everyone, Namaste. Welcome back to my channel AcademicTuber. Today we are going to discuss Unit 9 from Grade 10 Science, that is Heat. Before that, if you are new to this channel, please subscribe the channel and for more updates hit the bell icon. If you want more videos related to this, please like and to share this video among your friends, and also don't forget to give your valuable response in comment section. Thermal energy. It is the energy that comes from the temperature of matter. The hotter the substance, the more is the vibration of molecules, and hence the higher is the thermal energy. The sum of the kinetic energy of the molecules is the thermal energy. When the mass of warm water, tap water, and cold water are equal, the thermal energy of the hot water is the highest and that of cold water is the lowest. It is because the kinetic energy of molecules of warm water is greater than the kinetic energy of molecules in cold water. Heat is defined as a form of energy which brings sensation of warmth. Its SI unit is joule and is measured in calorie. It always flows from hotter body to colder objects. The total sum of kinetic energy of molecules of a body is called heat energy. The kinetic energy of each molecule depends upon its mass and speed of vibration. Thus, total kinetic energy contained in a substance depends upon the total mass of the molecules and average speed of vibration of molecules. Relation between SI unit and CGS unit of heat. The SI unit of heat is joule and the CGS unit is calorie, and 1 calorie it is equals to 4.2 joule. 1 calorie heat energy. It is defined as the quantity of heat required to raise the temperature of 1 gram of pure water to 1 degree Celsius. 1 joule heat energy. It is defined as the amount of heat energy required to raise 1 degree Celsius temperature of an object of mass 1 kg and specific capacity of 1 joule per kg degree Celsius. Effect of heat on molecules of solid matter are bound in a certain pattern due to the force of attraction between them. The force is known as the molecular force. However, they are not stationary but constantly vibrating. When a solid is heated, its atom or molecules gains more energy and their vibration increases. When the heat is continuously supplied, the atom or molecules vibrate rapidly. That is why the force of attraction between them weakens and they move away from each other, that is, the volume increases. When an object releases thermal energy, average speed decreases. Therefore, temperature decreases and the object contracts. In this way, most of the matter expands when the temperature increases and contracts when the temperature decreases. Anomalous expansion of water. The anomalous expansion of water is an abnormal property of water whereby it expands instead of contracting when the temperature goes from 4 degrees Celsius to 0 degrees Celsius and it becomes less dense. When most substances are heated, their volume increases, but water shows a different nature. Although its volume increases when heated, its volume decreases on heating from 0 to 4 degrees Celsius. Also on cooling down to 4 degrees Celsius, its volume decreases. But from 4 degrees Celsius to 0 degrees Celsius, its volume increases. Therefore, water at 4 degrees Celsius has minimum volume and maximum density, and this unique property of water is known as the anomalous expansion of water. So here is a graph that shows the relation between volume and density of water. On heating or cooling the water at 4 degrees Celsius, its volume increases and the density decreases. The density is maximum at 4 degrees Celsius and decreases below that temperature. The graph, the given graph gives a clear concept about the change in volume and density of water by its heating. We see many examples in our daily life related with this property of water. A few examples are given below. Effects of anomalous expansion of water. Air flows on water after rain. Ice flows on water. Honey and ghee solidifies from top to bottom, but water freezes from top to bottom. It is clearly visible in water bottle or cold drinks bottle kept in refrigerator. Cold drinks bottles are not completely filled, as space is left for the expansion of the liquid during freezing. A glass bottle filled with water completely is when kept in refrigerator. The bottle cracks if water is frozen in it. In cold region, or we can say Himalayan region, at very cold night, the closed water tap cracks. That's why in such region taps are left open. So here are few questions related with the anomalous expansion of water. Water pipe bursts during winter. Why? In winter nights when the temperature starts falling from 4 degree, falling below 4 degrees Celsius, water in pipeline expands and it exerts large pressure on the pipes, causing them to burst. Next one, icebergs flows on water. Why? Generally, density of solids is greater than that of liquids, but in case of water, the liquid density is greater than the density of ice. Therefore, ice flows on the water surface. Fish can survive in the temperature. Fish can survive in water below ice. Why? Water has maximum density and this volume at 4 degrees Celsius. Therefore, the sequence of the temperature of water from up to down is from 1 degree Celsius to 4 degrees Celsius. Because of this reason, water at the bottom is not frozen. It helps aquatic life to survive underwater. Heat equation. When a body is heated, its temperature increases. On the other hand, when a body is cooled, its temperature decreases. Let us consider a body of mass m having initial temperature T1 is heated by supplying Q amount of heat. Then its temperature rises to T2. Now the change in temperature it is given by dt delta T equals to T2 minus T1. That is final temperature minus initial temperature. It has been proven that the heat gain or lost by body is directly proportional to mass of body and the change in temperature. Mathematically, Q directly proportional to mass. That is, mass increases, amount of heat loss or gain also increases, and Q directly proportional to the change in temperature. If we combine equation 1 and 2, we get Q proportional to mdt or Q equals to ms dt, where S is constant called specific capacity of body. Therefore, Q equals to ms dt. Thus, the amount of heat loss or gain by a body is equal to the product of mass, specific capacity, and change in temperature. This above equation is known as the heat equation. Specific heat capacity. The amount of heat required to raise the temperature of object of 1 kg mass by 1 degree Celsius is called specific heat capacity of object. Different substances have different capacities of absorbing heat. Some substances when heated change their temperature faster and some need more time to change the temperature. It is because of different heat absorbing capacity of different substances. And this capacity of substance is known as the specific heat capacity. It is measured in joule per kg per degree Celsius. Different substances have different specific capacity, and the body having higher specific heat capacity changes their temperature slowly, whereas those having lower specific capacity changes their temperature faster. Specific capacity of some materials is tabulated below. Uh, Specific capacity of lead is 126 joule per kg degree Celsius. That of gold is 130. Mercury 140, silver 234, iron 470, that of sand is 800, glass is 670, water 4200 joule per kg degree Celsius, that of alcohol is 2400, kerosene oil 2010, ice 2100, paraffin 2100, air 993, and that of olive oil is 2000 joule per kg degree Celsius. So here is a question related with specific capacity. The specific capacity of water is 4200 joule per kg degree Celsius. What does it mean? It means that 4200 joule of heat energy is required by 1 kg of water to raise its temperature by 1 degree Celsius. The specific capacity of object differs. Why? The specific capacity of object differs because heat retention capacity of different objects is different. What are the factors affecting heat energy? The factors affecting heat energy are as follows. First one, mass of object, and second is the average kinetic energy of molecules. Consequences of the highest specific capacity of water. Water is used to cool the engines of vehicles. The specific capacity of water is very high. Every kilogram of water absorbs or releases 4200 joule of heat to change its temperature by 1 degree Celsius. This property makes water an effective coolant for cooling hot objects. Water is a substance having the highest specific capacity, that is 4200 joule per kg degree Celsius. It can absorb large amount of heat from hot engines without raising its temperature by significant value. Thus, it makes the engine cool. Next one, water is used in hot bags. Why? Water has a specific highest specific capacity, that is 4200 joule per kg degree Celsius. When water is heated to boiling point, it absorbs a huge amount of heat. The same heat is given out to the surrounding if it is placed in a hot water bag. Thus, the large amount of heat is made available for longer time. Next one, the night in desert is very cold, but days is very hot. Desert is full of sand. The sand has less specific capacity, that is 800 joule per kg degree Celsius. During daytime, sand gets heated faster due to absorption of heat from sun. At night, the sand loses heat rapidly and gets cooled faster. Thus, the night in deserts are colder, but days are hotter. So here is one numerical related with specific capacity. How much heat is required to raise the temperature of 5 kg of water from 10 degrees Celsius to 30 degrees Celsius? Okay. So here mass of water it is given 5 kg and initial temperature it is given 10 degrees Celsius, and the temperature rises up to 30 degrees Celsius, that is 30 degrees Celsius is final temperature. So therefore change in temperature delta T equals to T2 minus T1, which is 30 minus 10, 20. Specific capacity it is given in question 4200 joule per kg degree Celsius, but sometimes the value of specific capacity of water it might not be given in question. Amount of heat gain Q equals to what? Now we know the formula of heat equation. Q equals to msct, which is equals to 5 into 4200 into 20, which is equals to 42 lakh joule. Principle of calorimetry. Calorimetry is the branch of physics which deals with the measurement of quantity of heat loss or gain. According to the principle of calorimetry, when a cold body comes in contact with a hot body, the amount of heat lost by the hot body is equal to the amount of heat gained by the cold body if there is no heat lost to the surrounding, or we can say negating the heat absorbed by the surrounding. That is, heat lost by hot body is equal to the heat gained by the cold body. The resultant temperature obtained by mixing a hot substance with a cold substance is called equilibrium temperature, and equilibrium temperature is also called the final temperature. Temperature. It is defined as the quantity which measures degree of hotness or coolness of a body. The hotter objects have more temperature than colder objects. When a body is heated, the vibration of molecules containing heat increases, then the temperature too. The increase in vibration of molecules causes the increase in temperature. Thus, temperature measures the average speed of vibration of molecules. In other words, temperature is defined as the average kinetic energy of molecules of the body. That's why we can say that the temperature is directly proportional to the increase in the molecular vibration. The SI unit of temperature is Kelvin and it is also measured in degrees Celsius or centigrade and degree Fahrenheit. Thermometer. So we know that thermometer is a device which is used for measuring the temperature of body. It is constructed on the principle that liquid expands on heating and contracts on cooling. Laboratory thermometer. A thermometer which is used to measure the temperature of different chemicals, solvents, and reagents in the lab is called laboratory thermometer. It consists of a thick white glass tube having uniform and fine bore. The capillary tube is connected to bulb containing mercury at one end. The capillary tube is straight and it does not have any constriction. The esteem of laboratory thermometer is graduated in degree between -10 degrees Celsius to 110 degrees Celsius as shown in the figure. When the bulb of the thermometer is placed in contact with a hot body, the mercury of the bulb begins to rise and reaches a constant value. The temperature of body can be measured by keeping the thermometer in contact with the body. Next one is digital thermometer. It is a device for measuring the temperature of an object by using a heat-sensitive thermistor connected to an electric circuit. While using digital thermometer, the thermometer is turned on and the end of the thermistor is brought in contact with the body. Due to the heat transmitted from the body, the electric current in the circuit changes because of the change in the thermistor resistance. Based on this change, the measured temperature gets displayed as a number on the display panel. Third one is a radiation thermometer. It is a device for measuring the temperature of a body without contact. Its working principle is based on the intensity of the infrared radiation produced by the body. To use it, the sensor is turned towards the body. The lens in the device focuses on the infrared radiation coming from the object on the sensor. Based on the heat carried by the radiation, electric signals are generated and the temperature of the object is displayed on the display panel. This type of thermometer is very quick and easy to measure temperature. Calibration of thermometer. The graduation of number in thermometer between lower fixed point and upper fixed point is called calibration of thermometer. Lower fixed point is the fixed temperature at which liquid starts to freeze, and upper fixed point is the fixed temperature at which liquid starts to boil. Different thermometric scales. Celsius scale. In Celsius scale, lower fixed point is 0 degrees Celsius and upper fixed point is 100 degrees Celsius. In Fahrenheit scale, lower fixed point is 42 degrees Fahrenheit and upper fixed point is 212 degrees Fahrenheit. In Kelvin scale, lower fixed point is 273 Kelvin and upper fixed point is 373 Kelvin. So relation between the different thermometric scale is given by C minus 0 by 100 equals to F minus 42 by 180 equals to K minus 273 by 100. So here are a few reasoning questions related with this unit. Water in the other vessels remain cold even in summer. Why? Because water that evaporates from the pores of an earthen pot absorbs heat from the water inside the pot. So heat energy in the water of earthen vessel is less. Next one, water vapor is hotter than boiling water. Why? Because when steam vapor touches our body, it condenses into water and releases large amount of heat than hot water when it touches our body. Next one, a wet handkerchief is kept on the forehead of patient suffering from fever. When a person is suffering from fever, a wet handkerchief is kept on his forehead forehead to lower his body temperature. As the wet handkerchief contains water, it absorbs large amount of heat due to its high specific capacity. As a result, temperature of patient decreases. Therefore, a wet handkerchief is kept on forehead of patient suffering from fever. By this, we have completed nose of this unit heat. I hope this video was useful to you. If you like this video, please share with your friends and don't forget to subscribe. If you have any queries, drop the comment in the comment section. See you on the next video. Thank you.